Good morning, everyone. This marks the last unit or learning module for this semester for this particular course. So congratulations, you've come towards the end. Today, we're going to be talking about equipment specifications and shielding. Now, state-of-the-art diagnostic, radiographic, and fluoroscopic equipment has been designed with many devices that radiologists and technologists can use to optimize the image while reducing the radiation exposure to the patient. Now, although many safety features have been built into X-ray producing machines by manufacturers to ensure radiation safety, some features have also been included to meet the safety regulations. So when designing a X-ray room or ensuring that you have the correct shielding for the room, always bear in mind or keep in mind the safety regulations that apply in the country and make sure that those are incorporated in your plans. The objectives for today's lesson is to explain the equipment specifications and the general requirements for not only general X-ray equipment but fluoroscopy as well, and then to look at the shielding guides for diagnostic X-ray installations. With a focus on equipment specifications, it can be divided into either new equipment or existing old equipment. So let's start off with the new equipment. What is it that we need? When new X-ray equipment is to be purchased, the system components and the description of the design features of the room and the performance features of the equipment should be included in an equipment specifications document. Now, in general, the equipment specifications must identify all criteria which must be met for acceptance of that piece of equipment. When equipment specifications are prepared, the type of X-ray equipment needed and the types of clinical procedures intended to be performed should be identified. Selection of the equipment should be done with full knowledge of the clinical needs, the operational conditions, and the local safety regulation requirements. Like in this country, it is Qatar Law number 31. Testing equipment required to perform daily to monthly quality control procedures must be purchased at the same time as the X-ray unit. Any electrical, mechanical, and environmental conditions which may affect the performance of the equipment should also be included. Other relevant information includes details concerning the equipment installation, its calibration, associated deadlines for handover and installation, the warranty and service plan, and whether the training of staff is required from the manufacturer. Now, purchase of medical imaging equipment is expensive, and it becomes essential to ensure that the desired design and the level of performance is obtained in a cost-effective way while meeting the facility's needs. So when looking at old equipment or existing equipment, what are the specifications or the requirements? Whenever possible, existing medical X-ray equipment should be upgraded to incorporate as many as possible of the safety and performance features required of new medical X-ray equipment, as specified in the radiation safety regulations at the time, of course. The owner of the facility or a delegate, such as the radiation safety officer, must contact the appropriate regulatory authority for annual inspections of the facility and the equipment to ensure compliance with the applicable government regulations and laws. Now, during the time of the inspection, any deficiencies can be identified and it can be remedied. It is our duty and responsibility to understand the requirements, the Qatar Law 31, and any equipment specifications and requirements as laid out in the hospital policies that are enforced to ensure adequate protection for both ourselves and for the patient. So what are the three main categories of radiation found in an X-ray room, and how can we protect ourselves from these forms of radiation? So the three types are direct radiation, scatter, and leakage radiation. And which one are we most concerned with? Well, primary radiation is direct radiation, directly from the X-ray tube collimator to a certain point. A wall in the path of this radiation requires the most shielding. Most common primary radiation barriers are the walls or the wall Bucky unit, because the X-ray is moving directly from the X-ray tube to that point. And shielding must be appropriately calculated because you don't know what's beyond that wall. It might be a classroom, it might be a reception area, so shielding must be adequate enough to protect those in the adjacent room. And how about secondary radiation? Secondary radiation occurs when an X-ray beam passes through matter, and we know that the patient is the major cause of scatter. The resultant photons exit the object in all directions. Intensity and the energy and the penetrating ability of the scatter radiation is greatly reduced in comparison to the direct and primary incident beam, so the amount of shielding required to protect yourself from scatter is less than the protection required for the primary beam. However, we know that scatter radiation is most harmful to ourselves as the technologist working with the patient. And how about leakage radiation? That is the radiation in the X-ray tube that does not exit from the collimator opening. Leakage penetrates the protective tube housing and through the sides of the collimator, and it is always present. When shielding is planned for the secondary barrier, the potential for leakage must be taken into consideration. So a diagnostic type protective tube housing protects the patient and the imaging personnel from off-focus or leakage radiation by restricting the emission of X-rays to the area of the useful or the primary beam. The integrity of the X-ray tube housing that protects us from this leakage radiation is therefore essential, and it should be checked on a regular basis. Now, the leakage radiation from the X-ray source assembly of diagnostic X-ray equipment must not exceed an air Kerma rate of 1 milligray per hour at 1 meter from the source. In order to check this integrity, you can do a regular check by using a survey meter or a Geiger millicounter. Standing 1 meter away from the source, you set the highest tube voltage and MAS, and you take an exposure and you monitor the reading on the Geiger millicounter to see if it's above this or below this level. And this is the way to check the tube shielding or housing and that the leakage is minimized to below a certain level. Guidelines used for stationary general purpose equipment include general preventative maintenance. Preventative maintenance is necessary to prolong the life of the equipment. An annual inspection must be conducted for structural integrity, cleanliness, ease of movement of all the components, and any other procedures recommended by the manufacturer. Mechanical stability checks are required to ensure that the tube is securely fixed and aligned with the X-ray tube housing, and things like exposure linearity and reproducibility are checked to ensure the diagnostic X-ray unit's ability to duplicate certain radiation exposures for any given combination of KV and MA and time. If you think back to your image recording course that you done last semester, this links to linearity and reproducibility. If you remember, linearity in radiography is the production of a constant amount of radiation for a different combination of milliamps and exposure time. The assumption is that an increase in MAS should produce a proportional increase in radiation exposure within 10%, and if the X-ray unit is not functioning correctly, the unit must be serviced before being used again for diagnostic procedures. Linearity tests are performed not only to monitor image quality, but to assess variation in output intensity that leads to unnecessary dose to the patient from repeat X-rays as a result of that poor quality or faulty equipment. Now, reproducibility, if you remember, speaks to a consistent radiation intensity produced by the X-ray tube. In other words, repeating the same exposure on the same patient should give you the same optical density on the image. And the variance, if you remember there, was 5% or less, which was acceptable for reproducibility. Both of these points are quite important. I'm pretty sure that it will be brought up on your CAMRT exam if you ever wish to take it in the future. So remember, that's not only important here in this course and in image recording, but it will apply if you're ever taking that examination. So moving on, the general purpose radiographic equipment must have a beam limiting device according to regulations, and that is basically something that confines the useful beam before it enters the anatomic area of interest on the patient. The beam limiting device allows us to adjust the size of the X-ray field. There is a manual beam limiting device and there is a positive beam limitation or automatic X-ray field limiting device. For positive beam limitation, you know that the dimensions of the X-ray field should not exceed the area of the image receptor. Also, general purpose radiographic equipment must have an X-ray field indicator, and the X-ray field indicator should be visible under ambient lighting conditions in an X-ray room. Next, X-ray beam perpendicularity indicator must be available. You must have a way of checking that the X-ray beam and the light localizing beam of the collimator are in alignment. When it comes to manual, it should be within 2% of the source image distance. And when we are looking at positive beam limitation or automatic collimation, it should be between 2 to 3% of the source image distance. According to regulations, the patient's skin surface should always be at least 15 centimeters below the collimator to minimize exposure to the skin. Now, exposure to the patient's skin may be reduced through proper filtration of the radiographic beam. And if you remember once again from image recording, inherent filtration should amount to 0.5 millimeters of aluminum. Together, inherent filtration and added filtration comprise the total filtration. Now, stationary X-ray units operating at about 70 kVp are required to have at least a total filtration of 2.5 millimeters aluminum equivalent. And if you remember back to image recording, we do a half value layer test, we plot it on a graph, and this helps us to determine whether the X-ray beam has been adequately filtered based on a kVp setting. Filtration is important in removing those low energy photons from the beam and reducing the patient dose. And if you remember, compensating filters are also used in radiography to provide uniform imaging of the body parts when considering variations in thickness of the tissue or the body part. So filtration is quite useful. Other requirements for general X-ray include an exposure switch. That's a dead man type. So basically, if you put your foot on the exposure switch and remove it, it should automatically stop that exposure. When you are situated in the control booth, the exposure cord should not be long. It should be located in a position that is not possible to take an exposure outside of the booth. An emergency stop should be available to terminate the motion of the equipment and the emission of X-rays if it's needed. A warning sign must be present that is visible and legible, warning us and others of the hazards of X-ray that's being emitted when the equipment is in operation, and the use thereof must be prohibited. Only authorized people should be allowed in the area. The control panel or console must be located behind a protective barrier that has a radiation absorbent window and that permits observation of the patient during any procedure. Now, this panel must have an indicator light to show when the control panel is energized and the machine is ready to produce an X-ray, and the light should be visible when the X-ray is being produced. All controls, meters, and lights should be marked so you know what the function is. Indicator lights must tell us when the control panel is energized and ready for an exposure, when the X-rays are being produced, when the AEC is selected, and if it's a mobile machine, when the battery is powered and charged. Now at this point, I would like you to take a quick break before we move on to equipment specifications used for mobile imaging.